Hi there! In this video lesson, we will deal with Moody's K&V. Moody's K&V is one of the most important industry models out there for the estimation of the probability of default of a counterparty. Or, if we want to use Moody's terminology, instead of the PD, we will deal with the EDF, the expected default frequency. Now, the expected default frequency is nothing more than the probability of default of our counterparty over a 1-year time horizon. Moody's K&V is a structural model of default that originates from Merton's model. In a sense, Moody's K&V tries to overcome many of the weaknesses of Merton's model. For example, we substitute the normal distribution that you know is the distribution according to which we compute the probability of default of a counterparty under Merton's model with another distribution which is empirically computed. This new distribution allows for fatter tails, so for more extreme events, and you know that this can be much more plausible than the thin tails of a normal distribution. Then, for what concerns the liability level, capital B, under Moody's K&V, this is substituted with a more realistic liability structure that takes into account intermediate payments and not only the zero coupon bond with maturity capital T and face value capital B. And this also allows for the possibility of default before maturity, not only at maturity as in Merton's model. And finally, in Moody's K&V, we introduce a quantity called the distance to default that tries to simplify the relationship between the market quantities that we use as an input to compute the probability of default of a counterparty and the probability of default. We can use Merton's model in order to understand the most important characteristics of Moody's K&V. First of all, let's define the EDF according to Merton's model. This is the probability of default within 1 year. So in order to obtain this, we can start from the quantity we know. We set capital T equal to 1, so you see T disappears from the equation, and then we use the symmetry property of the normal distribution so that we can express our probability in terms of survival function. We then substitute capital B, that is the liability level according to Merton's model, with a capital B tilde, which is a more representative quantity of the complexity of the liability structure of a company. We are here considering all the liabilities that are payable within 1 year, so also considering all the intermediate payments. Then we substitute the entire argument of the survival function with a quantity, the DD, the distance to default, that we will define in a few minutes. And finally, we substitute the normal survival function, 1 minus capital phi, with an empirical survival function. This is essentially the way in which we can move from Merton's model towards Moody's K&V. As in Merton's model, also in Moody's K&V, the quantities V0 and sigma V are not directly observable and they need to be inferred from data. The starting point is more or less the same. We exploit the European call behavior of equity, of ST. To be more exact, Moody's K&V does not exactly rely on the standard formula for a European call, the one we have used so far under Merton's model, but they rather use a proprietary function that includes the formula of the European call, but also adds extra arguments, like, for example, the quantity D, that is the leverage ratio of the company under scrutiny, and the quantity C, that is the average coupon paid by long-term debt of the company, if this information is available, or of a homogeneous group of companies similar to the one we are interested in. Then, thanks to an iterative procedure, an iterative algorithm, we can compute the quantities sigma v and v0, that are the two quantities we still miss, that we need in order to compute the distance to default, a quantity that we are going to introduce in a minute, which is the basis, the fundamental quantity for the estimation of the EDF. As said, Moody's KMV tries to overcome some of the weaknesses of Merton's model. For example, the idea that default can only happen at maturity. This is a quite strong assumption. In Moody's KMV, this is not true. We are considering the possibility of intermediate default. And for what concerns the asset values, we know that asset values are not necessarily log normal as it is assumed by Merton's model. In fact, the empirical literature shows that very often asset values have heavy tails, meaning that large deviations are much more probable than what we would expect under a log normal distribution if we consider asset values, or a normal distribution if we consider the logs. Starting from these points of criticism, Moody's KNV introduces a quantity called the distance to default, DD as an acronym, which is probably the most important quantity under this approach. The DD may appear as a simple ratio, the one you see on your screen, but in reality is the result of a careful analysis of the default phenomenon. In this quantity, for example, you see the B tilde we were speaking about before, that is the new threshold we define, and it often represents all the liabilities that are payable within 1 year. In Moody's KNV, the distance to default, this guy, is used to approximate the argument of the survival function. In Merton's model, we use the normal survival function. In Moody's KNV, we use something else, something that we are going to see in a minute. If you are asking yourself how this substitution is possible, just notice that the difference of log v0 and log b tilde can be approximated by the expression you see on the screen, v0 minus b tilde over v0. For what concerns the difference between mu v and half of the variance of the asset, sigma square v, empirical evidence shows that this difference is negligible, very close to zero. As we have already said, Moody's KNV does not rely on the normal survival function, but rather on an empirical survival function, which is estimated on a huge historical dataset. This dataset collects the proportion of companies defaulting for different values of DD, of the distance to default, and for different time horizons. So here we are. In front of us we can collect all the ingredients we have been talking about in the last minutes, and we discover that the expected default frequency according to KNV, remember the probability of default within 1 year, it's nothing more than the probability we obtain by applying the empirical survival function we can estimate from the data to a specific value of DD that will be the measure on the basis of which we can make our evaluations. Two very different companies that share the same distance to default will essentially have the same EDF, the same probability of default over 1 year. Since I like to repeat stuff in order to make you understand, in front of you, you see another graphical representation of how we can move from Merton's model to Moody's KNV. As you see, we have the different ingredients The liability capital B is now substituted by the liability threshold capital B tilde. The probability of default is now what we call the EDF, okay, but this is just a minor change. But most of all, the log normal distribution, the normal distribution in the logs, it's substituted by an empirical counterpart, by an empirical survival function that we can estimate from data. And while in Merton's model the assets follow a geometric random motion, in Moody's KMV this is not really relevant. Actually, you can still prove that this is true, but it's not really relevant because the PD depends on the DD, the distance to default. As Merton's model, Moody's KMV is a capital market model that uses information from the market to compute the probability of default of a counterparty. In fact, the DD, the distance to default, incorporates information about the equities, about their value on the market. This makes Moody's KMV react quickly to changes in the economic prospects of the counterparty. And the DD also incorporates information about the macroeconomic scenario in which we are making our evaluations about the probability of default, or the EDF in this case, because you can imagine that the prices on the market incorporate expectations about the economic situation in which we are making all our evaluations. Being a capital market model, one of the limitations of Moody's KMV is that it is typically available for traded companies, companies that are listed on the market. So for the small company behind the corner, it's quite difficult to use Moody's KMV, at least in this version. Moreover, since this model reacts quickly to changes in the economic prospects on the market, essentially it can be affected by the problem of procyclicality that for example, when we deal with value at risk and all the discussion about the procyclicality of value at risk, it's quite a relevant problem when we deal with credit risk. Once again, more details can be found on the course platform. For the moment, I want to thank you for your attention and say goodbye.